Hello, this is Kai for the final project of EEL6825. I have created the MATLAB files to run the program and realizing the two methods I have mentioned in the previous video, the logistic regression and neural network. So let's first talk about neural network. No, logistic regression, I'm sorry. The program main is showing here. And here I have imported data from my Excel sheets, the breast cancer data. The medium is used to fill in all this missing data, so this is a complete. And this is going to assign the value to A. So we can look at here that A is 699 by 11 matrix. There are 11 attributes and 699 samples. And then I'm going to assign the training data set to be 2/3 of the total amount of samples and the testing data set to be 1/3. And then after separating the train data set and the testing data set, I have allocated the values to be the input X or the values to be the output Y. And using the input and output, we'll be able to construct the logistic programming. So now I have my train data set here, and I assign the number of samples and features in there to the input into the random function. So random function is going to generate a width parameter matrix, and this width parameter matrix is inertialized. And then we can look at the calling function we use to calculate the weight. So inside the width, I have the inputs of X training data and Y training data, and giving an inertialized W, and the maximum iteration is defined over here to be 10,000 runs, and the amount of learning rate is 0.1. So given the size of the train and when I'm going to iterate through 0 to 10,000, this for loop is gonna break either when the value has been reaching to the maximum iteration, or that my difference between the cost function change is less than 0.01%. So that means my program is not going to improve anymore. So that's the bottom fixed point. And inside here, for each samples, I'm summing together the sigmoid function times the weight factor, and the hypothesis function times the weight factor minus the real value. The actual value is the Y train, and then times the X for the specific sample. And then this is going to give me the stepping for the W factor, and W has been summed over the inertialized W, and then plus the learning rate times the total amount. And then the cost function is defined here. Let me see. Cost function is defined to be as we have went over on the log. When y equals to 1 is just a log of hypothesis. When y equals to 0 is log of 1 minus the hypothesis. And this is iterated throughout the whole sample. So the cost function is a sum of those individual costs and then divided by the total amount of samples here, the total amount of sample. And then when we go back, so when this one is breaked out, we have generated the weight factor. And let's go back to the main. After we have gotten the weight factor, we're gonna use this weight here and then assign it to the classify function. In the classify function, we have the input factor for the testing set, the features X. And then we want to generate the results, which is the classified outcome, and that is going to be in here. So inside is just plugging into our classification function and checking the signal function with regarding to 0.5 point. Less than that, you're gonna get a 0 value, and more than that, you're gonna get a classified 1. So after getting that, we're just gonna try to look at the errors. The errors is the difference, the total sum of the difference of all those samples adding up together, and the error matrix is calculated to check the confusion matrix, which gives us the type 1 and type 2 errors. So now we can look at the results I have here. So the total amount of samples that we use for training is 466, and the features are 9. The error matrix gave us correct for classify as 0, 175. Correct classification for 1 is 54. So there's no type 1 error, but type 2 error has 4 samples. The total amount of errors is 4. The percentage of error is 1 minus this accuracy. So after we're getting that, we want to further look at the ROC curve. The ROC is plotted by using this function, perf curve, and then we're using 1 as the intended target. So the AUC is going to give us the area under curve, and that value is here. It's 98.88%. Okay, let's look at the graph I have here. So the graph shows a really sharp transition, and the areas underneath is a lot. So if you draw the line here to separate the two areas, you'll see the performance is really well. So that's it for the logistic regression. And now let's look at the neural network. I'm just gonna show how it actually got done. It's really simple. So let's start with the neural network toolbox that's built in the MATLAB. So we choose pattern recognition, and then we can see this is a demonstration of what is going to be done in this program. It has taken input and it got a hidden layer defined, output layers defined, and then you're gonna get results of classified category. So input data, we can just load this breast cancer. This is 9 times 699, the same data set we have on the logistic regression, and then we're gonna import. So we go to the next, define the division between different settings, different data set, training 80%, validation 10, testing 10. And then we go to next. The number of hidden neurons. In this example, we did 10 neurons and 20 neurons, and they yield different kind of results. So right now, we're just gonna use 10 as an example. So when you go to the next, it will show you the interface for you to train it. So we're gonna train. This will take really fast. This will take an offset and bias that's arbitrary, and then will generate results. So the results coming out is gonna be a little bit different every time. So if we do retrain, the value has become different, and then we do another one. And this is a variation, so that shows the validation is probably not the best, and we should try to use a cross validation instead of this case. But this is just an example. So we have the confusion plot. Type 1 error, type 2 errors, and the correction rate is 97.5, and the testing is 95.7. So this fits better on the training set instead of on the test set. And also the ROC curves can be generated as well, and you will see that the ROC curve is showing better to be on the training and a little bit worse on the test and validation. So now you get the options of actually exporting the code from this toolbox, and that's what I did. So therefore, I have attached the MATLAB to the zip folder for all the programs. So I wanted to go up. I think that's it for this project.